Welcome to Bodhi Academy. My name is Amisha Kulaso, and in today's class we will see the chapter Fractions and Decimals of class 7. So now, to understand fractions, we know what are fractions. So when we say fractions, we simply mean that they are in a rational number form. So now, in the previous video when we studied about rational numbers, we denoted them in P by Q form, and where Q is not equal to 0. Similarly, in the same form we have our fractions over here. So we'll see now in this chapter, we'll see how to multiply these fractions, then multiplication of fraction by a whole number, and multiplication of a fraction by another fraction. So let's start. So multiplication of fraction. So you know how to find the area of a rectangle. So when we talk about area of a rectangle, say we have to find area of rectangle. What we simply do here is length into breadth. So here we have, say we have 7 into, say we have 4 is the breadth. So our area of the rectangle will be 28 centimeter square. Now this was a simple multiplication because these are whole numbers. Okay. But now say I give you length equals to, say we have length 7 1 by 2. Okay. And our breadth equals to, say 3 1 by 2. So now what will be the area in this case? Okay. So what we'll do, we'll say is area of rectangle will be equal to, so our length is 7 1 by 2 into 3 1 by 2. So now how do we solve such kind of fractions which are given to us? So now let's try to understand that. Okay. So now here they have given a simple example. So they have a circular shape, and in that it is divided into 4 equal parts. Out of that, one part is shaded. So now let's see what they say. Observe the picture at the left. Each shaded part is 1/4 part of a circle. So now how do we know it is 1/4 part? See, it has total of 1 2 3 and 4. So this, out of this, okay, how many parts are shaded? 1. And how many total parts are there? That is 4. So that is how they say each shaded part is 1/4 part of the whole circle. Now how much will the two shaded parts represent together? So now here similarly they have another one. Okay. So here also it is 1 upon 4. So now they are asking what will be, how much will the two shaded parts represent together. So this plus this, they are asking how much will this be. So they have done, what they have done is here 1 upon 4 plus 1 upon 4. So this will be equal to 2 upon 4. Now another way you can write this is, you take this 2 out, and what will be left here is 1 upon 4. So again if you multiply this, you will again get 2 by 4. So they are saying it is 2 1 by 4. So combining the two shaded parts, we get figure 2.2c. In that, two parts are shaded. So this means, see, now there are 1 2 3 and 4 parts again. Again here there are 2 parts are shaded, so it will be 2 by 4. Now see here, in this example the shaded portions in figure 2.1 taken together are same as the shaded portion in figure 2.2. So we get figure 2.3. Now here if I have to write this, what will I write? Again there are 1 2 3 and 4 parts. So this is equal to 1 upon 4, and again this equals to 1 upon 4. So this together will be equal to 2 upon 4. Now let's try and solve this picture. So in this case, again we have 1, 2, 3 and 4 parts to each box. So here we'll get, first will be 1 upon 4. Then again we'll have 1 upon 4 and 1 upon 4. So now we add all of these. So 1 upon 4 plus 1 upon 4 plus 1 upon 4. So this will give you what? 3 upon 4. So that is what we are getting here. So here this box has 4 parts, out of which 3 are shaded. So we get 3 upon 4. Now further, see this box now. So here there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Now out of 9 parts, only 2 are shaded. So we'll write 2 upon 9. Similarly here, again 2 upon 9, and here also 2 upon 9. So this will be equal to 2, because the denominator is same, I'll directly write it upon 9. So this will be 6 upon 9. So here there are 1, 2, 3, 4, 5 and 6 parts that are shaded, and 7, 8, 9 out of total 9 parts. Now let's see how we will find 3 into 1 by 2. So now when we say 3 into 1 by 2, what it basically means is that there are 3 parts. Okay, so there are 3 different circles having, so it is like this. Say I have a circle, this part is shaded, okay, and I have another circle, again this part is shaded, and I have another circle and this part is shaded. So when I add this, this will be what? 1 by 2, 1 by 2 and 1 by 2. So in this case 1 plus 1 plus 1 upon 2, because they have the same denominator, it will be 3 by 2. So that this, if I have to write in a simplified version, I'll write it as 3 into 1 by 2. That is what they have given here. Now, so now these all that we considered were proper fractions. So now when I say proper fractions, we know that proper fractions, here the numerator, okay, so here proper fractions, okay, here the numerator is smaller, okay, and the denominator is greater. So these are now proper fractions. All these that we solved are proper fractions, because here see the numerator is small and the denominator is greater than the numerator. Now when we say improper fractions, it will be reverse. So in improper fractions, we'll have the numerator is greater and the denominator is smaller or lesser than the numerator. So now for improper fractions, we also have the same way. So here see, now we have, they have given 2 into 5 upon 3. So this we can simply multiply. So it will be what? 2 into 5 upon 3. So this will be 10 upon 3. Okay. Now if we try to solve this one, we'll get, what we'll get is, here we'll get 8 3s are 24 upon 7. And here what we'll get is 7 4s are 20. 8 3s are 24 upon 7, and here 7 4s are 24 upon 5. So to multiply a whole number with a proper or an improper fraction, we have to multiply the whole number with the numerator of the fraction and keep the denominator the same. That is what we are doing. We are multiplying only these two numbers, and this we keep it as it is. Okay. So now to multiply a mixed fraction to a whole number, first convert the mixed fraction to an improper fraction and then multiply. So now what they are saying is, now this part which is there, see here, this is the mixed fraction. So now how do we solve such parts? Okay, so let's take that same example. So it said 3 into 2, 5 by 7, 5 by 7. Okay, so now this part which is there is the mixed fraction. Okay, now this we have to convert to a, they have said convert it to a improper fraction. Improper fraction. So how do we do that? Now what we have to do here is keep the 3 as it is, and let's first solve the improper fraction part. Okay, so we have 2 into 5 by 7. So how do we convert this? Is what we do, we multiply these two numbers. So we'll write 7 into 2, and this then we add. So we write plus 5 upon 7. So now this will be equal to what? 7 2s are 14 plus 5 upon 7, that is equals to 19 upon 7. So now we have got a improper fraction. Why improper? See here, the numerator is greater than the denominator. So now we can easily solve this. So 3 into 19 upon 7. So this will give us what? 19 3s are 57 upon 7. So this is our improper fraction. Okay. So now this fraction we can further write it in a even simplified form, that is, say I have this, we can again write in a mixed fraction form, in this form. So we know our denominator will be the same, that is 8, and here what we'll write is, so what we can write here is 8, because when we multiply 8 into 7 we get 56. So this will give us 56. So now we have to get 57. So here we'll have to write 1. So when you add that 1 over here, you will get 57. So 57 upon 7. Okay. So now let's solve another one. Say we have 2 into 4 into 2.5. So again, first we solve the mixed fraction to get it to improper fraction. So here we'll have, what we do first is upon 5. This we multiply and this we add. So here we'll get 4 5s are 20, plus we have to add 2 upon denominator remains 5. So we'll get 22 upon 5. This we multiply it with the 2, this 2 which is there here. So we'll get 44 upon 5. Okay. So yeah. Yes. Okay. So let's move ahead now. Fraction as an operator of. So now what they are saying here. So the two squares are exactly similar. Okay, here these squares are similar. Each shaded portion represents half of one. So this whole, it is a one square. So only one part of it is shaded. Sorry. So this is 1 and this is 2. So it has two parts. As a whole, it is 1. So it will be 1 upon 2 of 1 here. Okay. So now what they are trying to tell us here is, so when we say half of 1, this of basically represents multiplication. So it is half into 1, that is 1 by 2 itself. So now say here they have an example. Okay. So Frida has 20 marbles. Reshma has 1/5 of the number of marbles what Frida has. How many marbles Reshma has? As of indicates multiplication. Okay, so now they are saying Reshma has 20 marbles here. Okay, and Farida has 20 marbles. Okay, and Reshma has 1/5 of the number of marbles of what Farida has. So they are saying what is 1/5. If it is of means it is multiplication into total marbles are 20. So they are asking now how many marbles do Reshma has. So here we can directly multiply. So this if you multiply you will get 20 upon 5, and here 5 ones are 5 and 5 fours are 20. So in that case Reshma has 4 marbles. Okay, now moving ahead, let's try to solve this one. In a class of 40 students, 1/5 of the total number of students like to study English, 2/5 of the total number of students like to study maths, and remaining students like to study science. So now what they are saying is we will solve it here itself. So a class has total, it has 40 students. Okay, now they have said that 1/5 of the students like to study English. So 1/5 of 40 they like to study English. Then 2/5 like to study maths. Of 40 they like to study maths. Okay, so now how they want to know first. So the first question here is how many students like to study English. So now this we know. So if it says 1/5 of 40 means it is into 40 here. So here we'll get 40 upon 5. So 5 ones are 5, 8s are. That means out of 40, 8 students like to study English. Okay, now we have 2 by 5 of 40. So 2 by 5 into 40. So now this if you multiply you will get 80 upon 5. So 5 ones are 5, 3. So this will be 6. So 16 students like to study maths. Okay, now the next question is what fraction of the total number of students like to study science. So now they are asking how many students like to study science but in fractional form. First we'll try to solve it in a simple manner. So we know already now there are 40 students out of which 8 like English, then rest 16 like maths. So now we only have to do is, so now here we'll find first how many like maths plus English. So that is we have 8 plus 16, that is 24. So 24 students out of 40 they like maths and English. Now obviously it means that the rest out of 40, so 24 minus 40 will like what they will like, that is 16 will like science. So now this you have to write in a fractional form. So what we'll do here is, say we have 16 upon 40. Okay, this is the fraction. This if you cancel out you will get what, 4 4s are 16, 4 2s are and 0, 4 1s are 4 5s are. Okay, so sorry, here it is 2 2s are and 2. Okay, just 1 second. So this will be, so we have here what we'll do is, this is 2 8s are 16, we have 2 2s are 4 and 0, then 2 4s are and 2 5s are, sorry tens are. So here 2 twos are and 2 fives are. So we get 2 upon 5 here. So of 40 students. So now this, if we calculate, we should get back 16 as the answer. So 2 upon 5 into 46. So this, if I cancel this, 5 ones are 5, 5 eights are 40. So 8 twos are 16 students. So which means our answer is correct. Okay. Now let's move ahead. Okay. Let's quickly try to solve these examples. So now which of the drawings A to D show the respective? So now these drawings we have to match to these numbers. So now here we have what? This is 1, 2 and 3. So this is what? 2 parts are shaded out of 3. So 2 by 3. Again 2 by 3 and 2 by 3. That will be total equal to, if we add all, we'll get 6 by 3. That is, okay, so we'll get, yeah, 6 by 3 will get here. Now this is 1 by 2, so 1 by 2 and 1 by 2. This will be equal to 2 by 2. Okay. Next. So next we'll have this. So this is 1, 2, 3 and 4. So this is 1 by 4. 1 by 4, 1 by 4. This will be 3 by 4 for us. And this is 1, 2, 3, 4, 5. So this is 1 by 5 plus 1 by 5, that will be 2 by 5. Okay, so now let's try to match this. So now let's look at 6 by 3. So this 6 by 3 which is there, we can also write it as 3 into 2 by 3. So this will become, this if you multiply it will be 3 2s are 6 upon 3. So do we see the answer here? Yes. So our third one is this depiction. Okay, so we'll change maybe colors. So this is our third one. Next we have 2 by 2. So in this case, this we can even simplify as 2 into 1 by 2. So 2 into 1 by 2, yes. So this one, this second one. Okay, so this figure represents this part. Then we have 3 by 4. So 3 by 4 we can again represent as 3 into 1 by 4. And it is here. So this is fourth one. And lastly 2 by 5, again 2 into 1 by 5. So that is this one here. Okay, so that is how we have to match this. Now let's solve these ones. Okay, so we'll solve the first one. So 7 3s we know is 21 upon 5. What they have told is multiply and reduce to lowest form and convert it into a mixed fraction. So now we know this, you multiply, so you get 21 upon 5. So this you can write it as, our denominator will be 5. So you can write here 4. So 5 4s are 20 plus 1. So 4 into 1 by 5 is the mixed fraction for this one. Then we have 4 by 3. So this will be what? Again we'll get 4 by 3 will get. This we can write it as, so denominator 3, here we'll put 1. So 3 ones are 3 upon 1 plus 1. So this is multiply and this is plus. So that is how we solve these examples. This we already know. So if it is off means it is multiply. So if we have 1 by 2 of 24. So this I can cancel out. 2 ones are 2, 2 ones are 2, 2 twos are 4. So we'll get 12 here. So similar way we have to solve all of these problems. So now multiplication of a fraction by fraction. So now when we have multiplication of a fraction by fraction, what we basically do is we simply, okay, so here what we do, say we have a upon b into a upon b. So we write we multiply the two numerators. Two numerators. Okay, and then here we have multiply the two denominators. Okay, so we simply do with this, multiply this and we multiply this, so it will be A upon B. So that will be like, say I have 2 into, sorry, say I have here 2 upon 3 into 5 upon 6. So I multiply this 2 into 5 upon 3 into 6. So this will be equal to 5 2s are 10 upon 6 3s are 18. So that is how we multiply a fraction by another fraction. So now let's try to fill in these boxes. So 1 into 1, here we have to multiply first two numerators. So 1 into 1 is 1, and then 2 into 7, 7 2s are is 14. So 1 by 14. Similarly here we'll get 1 upon 7 5s are 35. Here we'll get, so here you can write it in this form, 1 into 1 upon 7 into 2. So this will be again 1 upon 14, and here again we'll have, so no matter how you interchange, your answer will remain same. See here, they have just interchanged the two numbers and yet the answer remains the same. So now, so see here, so multiplying of two fractions, as you write the product of the two numerators and then product of the two denominators, that is you multiply these two and you multiply these two. So now something very interesting that we need to know over here is that when we have, say, okay, we have, say, we have proper fractions. So now when we have proper fractions, say I have 2 by 5 into or of 1 by 3. Okay, now these are proper fractions. The denominator is greater than the numerator. So now let's first solve this. 2 upon 5 into 1 by 3. So this will be equal to what? 2 upon 5 3s are 15. Now let's try to compare this answer with each of these fractions. So now we know when we have to compare, we have to make the denominator same. So here we already have 2 upon 15. So here we'll write into 3, which will give us 3 2s are 6 upon 15. So now see here that 6 by 15 is greater than 2 by 15. Now let's do it for the other one. So 3 into 5 will give us 5 upon 15. So here again we have 12 by 15. So in this case, now see here the sorry, this is my bad. Okay. See, so now here again the fraction is greater than the product. So now what we are trying to tell here is that there is a common observation made that when it is a proper fraction, the product will be always less than the individual fractions. See, now here our product was 2 by 15. So first we compared it with 2 by 5, that gave us 6 by 15. So here our individual fraction is greater than the product fraction, and similarly we saw it in this case. Now let's say we have improper fraction. Now let's see what happens when we have improper fractions. Okay, so in this case improper fractions, let's take an example. Say I have 6 by 2 of 5 by 3. So now let's solve this first. 6 into 2, 6 upon 2 into 5 upon 3 will give 6 5s are 30 upon 3 2s are 6. So 30 by 6 is the answer. Now let's try to compare it with first 6 by 2. So 2 into 3 into 3 will be 6 3s are 18 upon 3 2s are 6, and we have 30 upon 6. So here our product is greater. Then we have 5 by 3 into 2 into 2, this will be equal to 10 upon 6. So in this case again we have 30 by 6, again our product is greater. So now here the observation reverses. So in case of improper fractions, okay, here the individual fractions are less than that of the product, which means the product values are greater than that of the individual fractions. Okay, so these are the two observations that we need to remember. So in today's video, what we will learn is that first we learned how to multiply two fractions. Okay, we learned to multiply two fractions, then we learned to multiply a fraction with a whole number. Further, we saw that how to use fraction as an operator of. So when there is a word of, it tells us that it represents multiplication sign. Then we solved some word problems, and then lastly we saw how to multiply a fraction by another fraction. We also saw what happens when the values of the products with the individual fraction changes. We saw when it is proper fraction, the product is less than that of the individual fractions, and in case of improper fractions, the individual fractions are less than that of the products, that is the products are greater. So thank you for watching today's video. Please don't forget to like, share and subscribe to the Bodhi Academy.